Okay, we're going to review an uncoupled two-spin system. So for a one-spin system, to remind us, a one-spin Hamiltonian, we would typically write that as omega, the IZ operator. So for two spins, we basically reproduce this twice, keeping track of that these can have, each spin can have a different frequency. So, and also different angular momentum. So this is for no coupling between the spins. So you have several, your wave functions for each spin, which we've reviewed in the past, we call alpha. So they can both be in the alpha state. One can be in the alpha and one in the beta, or vice versa. Or they can both be in the beta state. So these are the wave functions that describe it. If we just pick one to look at, so how the Hamiltonian operates on this will be equal to omega 1. I'm just moving the 1 inside it. You can imagine, convention-wise, I often leave out the commas and swap the space of 1 and 2's here. Okay, so this will be equal to 1/2 minus 1/2 the wave function out. And you can see this because the IZ operating here will give, a 1/2 out, and the IZ operating on this one will give minus 1/2 out. Okay, there would also be an H bar in there that we absorb. So now looking at a table of this, if we think about the quantum numbers, and there's 2 now, what we call the spin state of the system, what the eigenfunctions are, which we've listed above, the eigenfunctions, and then our eigenvalues, which we just looked at one specifically, which are, because this is the Hamiltonian, these are energies. So again, we have plus 1/2. They can both be in plus 1/2. We call this alpha alpha, right? We've seen the wave function here. Looks like that. We also sometimes in direct notation write it like that, or sometimes we'll just do 1/2, 1/2, and we usually put pluses there. And the eigenvalues, this would be plus 1/2 omega 1, plus 1/2 omega 2. All right. We've seen the second one explicitly, where it's in plus 1/2 minus 1/2 quantum numbers, which is spin state is alpha beta. I'll summarize this as just saying beta like this, not to show all the other forms. And then we've seen this one explicitly above. So you can just tell whether it's operating on alpha to give plus 1/2 or beta to give minus 1/2, what each of these uncoupled terms are going to look like. This one's just going to flip it around and in both the spin state and the energies. It's going to put a minus a half on omega 1 and plus a half on omega 2. And then finally, when they're both in the beta state, okay, and that gives you a summary table of, an uncoupled two-spin system Hamiltonian.